The assignment problem is included in this session because they are very similar. In fact, they can be converted into transportation problem and then solved using the techniques for the transportation problem. Let's illustrate the assignment problem with the help of an example. In this example, a company is having 4 number of machines which are available for assignment to 4 number of tasks. So there are 4 number of machines which are able to do 4 number of tasks. Any machine can do any task, and each task requires processing by any one of the machines. The time required for setup for each machine is given in the table here. So for example, for machine number 2, to perform task number 2 requires 11 number of hours. The company wants to minimize the total setup time, so you have to find the assignment of task to a particular machine such that the total setup task can be minimized. Now, the first impression one may get is that it's very simple problem. So intuitively one may think that for assigning task number 1, we'll find out machine which is having least number of setup time. So in this case, we have 2 candidates, machine number 2 and machine number 4. So let's say we are selecting machine number 1 for task number 1. For task number 2, you will select the next machine which is having least time. So in this case, it is the machine number 4. For task number 3, you will select the machine number 3 which is having the least time. And since now all machines are exhausted, for task number 4, you have to use machine number 1. If you add up all the setup times, you will find that the total setup time is equal to 12 hours. As we can see later, this is not the optimal solution. So if the number of the assignment problem is large, then finding the solution just by observation may not be possible, and hence we are looking into more proper solution to this particular situation. Let's see how do we convert an assignment problem into a transportation problem. The machines can be looked as the origins or the warehouses. Now instead of products, these origins contain services. So each of the machine can provide a unit of service to complete the destinations, which are here the tasks. So each of the machine has got a 1 unit of service which it can provide to satisfy any of the tasks, and each of the tasks demands 1 unit of service from any one of the machine. So that makes the relation between the assignment problem and transportation problem to the first level. In the same logic, the setup times which are given in this table can be considered as transportation cost. So for example, if we consider the service provided by machine number 2 in order to satisfy task number 3 is costing 5 hours, and that can be treated as the cost of transportation for this particular case. Now we have to talk about the quantities which are dispatched from origin to destination. In this case, the quantities are nothing but the services, and each service can be supplied only once. That is, each machine can satisfy only one of the tasks. So in that sense, each of the quantity getting transported can be either 1. That is true if machine I is providing it is catering to task J, then the quantity will be 1, and if it is not assigned, machine is not assigned to task J, the quantity will be 0. So in this sense, we can convert the assignment problem into a transportation problem, and you can write the transportation tableau for the assignment problem. We'll see how the tableau can be written for the given problem. So in this case, we are having 4 number of machines, which are the 4 origins. So each of the machine has got a single unit of service available, and each of the task demands a single unit of service from the origins. And the cost of transportation is nothing but the setup time. So for the task from first machine, for the first machine to first task, it is 13 hours, 4, and so on. We can complete this particular table, and that is how the transportation tableau will be ready. Once this tableau is ready, we can apply the transportation method technique and obtain the solution. Once the tableau is ready, we can obtain the solution, and further details of this particular method one can read from the handouts which are provided. As a final solution to the current assignment problem is given in this tableau. So the solution given here has got a total setup time or cost which is equal to 11 hours, which is less than estimated by us earlier manually as 12 hours. So this is the least time that is required for this particular problem. Another observation is number of basic variables in this case will be equal to 4 plus 4 minus 1, that is equal to 7. So you will see the 7 variables here, and you will note that some of the basic variables are having a 0 number. So this is known as a case of degenerate solution. In the assignment problem, usually you will find that solutions are degenerate, that is, some of the basic variables are having 0 values. This concludes our discussion about the assignment problems. Let's summarize the session. We have discussed about the features of transportation problem and learned a method to balance a transportation problem. The transportation tableau, which is the basic format used to solve the problem, is described. The steps involved in obtaining the final solution are outlined. We have also discussed about the similarity between transportation and assignment problem. A procedure to convert the assignment problem to a transportation problem is explained. At the end, I thank you for your time and attention. Goodbye everyone, and see you in the next session.